Hello everyone. In this video we're going to be solving a nice exponential equation. We have 27 to the power x plus 12 to the power x equals 2 times 8 to the power x. And we're going to be solving for x values. Now I'll be presenting two methods and let's start with the first one. Now to solve this problem I'm going to go ahead and factor each of these numbers 27, 12 and 8. The prime factors will tell us kind of what to do, okay? So, for example, 27 can be written as 3 to the third power. Therefore, 27 to the power x can be written as 3 to the power 3 to the power x, which I can also write as 3 to the power x to the third power. And then 12 is 2 to the second power times 3. So 12 to the power x can be written as 2 to the power 2 to the power x times 3 to the power x, which can be written as 2 to the x squared times 3 to the x. And then finally 8 is 2 to the third power. And from here 8 to the power x can be written as 2 to the power 3 to the power x, which can be written as 2 to the power x to the power 3. Now looking at these three things, we can use substitution. And there are two different variables here. One of them is 3 to the power x, the other one is 2 to the power x. Obviously they are related, but at the same time they're also different, right? So let's go ahead and do this then. Let's set 2 to the power x equal to a and 3 to the power x equal to b. This way we're going to be getting an interesting equation in a and b. So starting with the 27 to the power x, which is 3 to the power x to the third. Obviously, since this is b, 27 to the power x would be b cubed, right? So I'm going to go ahead and rewrite the original problem one more time and then just replace it with what it is. So we're going to replace this with b cubed. 12 to the power x is going to be a squared times b, and 2 times 8 to the power x is going to be 2 times 2 to the power x to the power 3, and this is a cubed, okay? So we're kind of getting a cubic equation from here, from an exponential to a cubic. How nice is that, right? Now let's go ahead and put it all together. B cubed plus a squared b minus 2a cubed equals 0. Now there's a couple ways to go about it. You can actually do something that's pretty interesting here, which is a general method that works with these kinds of scenarios, but this is a cubic case. You can go ahead and actually divide everything by b cubed as well as a cubed, but I'm just going to use b cubed in this case. And if you divide everything by b cubed, provided that b does not equal 0, this will give you 0 on the right hand side, and the left hand side is just going to be 1 plus b goes into b cubed, b squared times, so it's going to be a squared over b squared minus 2 times a cubed over b cubed. And that's going to equal 0. Of course, I could also divide by a cubed. That would probably be better because that would keep my original expression in a positive way, but it doesn't really matter. No big deal. Okay, we can still take care of this. Now notice that we can multiply everything by -1 so that we can have the highest power first with a positive coefficient, right? Like this. And then here's what we need to do. Substitution again. This can be written as a over b to the third power. And that basically calls for what? A over b being set equal to something, right? So let's go ahead and set a over b equal to, I don't know, t maybe. If a over b is t, then you get 2t cubed minus t squared minus 1 equals 0. So that's one way to go about it. I'll show you an alternative, okay? Now, this is a cubic equation. I know there are ways to solve cubic equations, but actually this is a special one. Why? Because t equals 1 is a solution, as you can immediately see, hopefully, right? 2 minus 1 equals 0. So since t equals 1, factor theorem tells us, hey, t minus 1 needs to be a factor. Therefore, we can either use long division or just factor this accordingly. Here's how I would proceed. To get a t minus 1, I would just subtract 2t squared because this would basically give me 2t squared multiplied by t minus 1. If you do this a lot, then you'll get used to it. And of course, I need to get at the end minus t squared. So I have to add t squared to this. And then I will continue with minus t so that, again, I'll get t minus 1 as a factor. So that's my goal. I always want t minus 1 to be a factor for all terms. And then, finally, we have to add t because we didn't have a t in the original problem. And of course, we need to finish with minus 1. And this works nicely. Now we're going to do factoring by grouping. Like I said earlier, 2t squared times t minus 1 plus t times t minus 1. And finally, 1 times t minus 1 equals 0. And of course, t minus 1 is a common factor. We'll pull it out. We'll get 2t squared plus 2t, or not 2t, sorry, I had to say that, plus 1 equals 0. Okay, the second factor is actually quadratic, so we should be able to solve it easily, right, with the quadratic formula. So we know already t equals 1, but let's rewrite it. So t from the quadratic becomes negative b plus minus the square root of b squared, which is 1, minus 4ac, that would be 8. Houston, we're getting non-real solutions, okay? And this channel normally does not deal with those, but I'm still going to talk about them briefly. But if you think about what the square root of the square root of negative 7 is going to be, that's going to be the square root of 7 multiplied by I, because I is the square root of negative 1. And from there, we get the following solutions. And of course, we kind of need to remember what t is, right? What did we replace t with, or what did we replace what with? We did replace what with t. Okay, that's what I was trying to say. A over b equals t, so we can now go ahead and replace t with a over b. A over b equals 1 basically gives you b equals a, or a equals b. Let's just deal with that first before we get into complications and complexifications. Now, if you remember, b equals a actually gives us a really good thing, because now we have this equation. Let's go ahead and rewrite it. B cubed plus a squared b. B cubed plus a squared b. I think that was equal to 2a cubed, but let's double check. Yeah, that's equal to 2a cubed. So now we can go ahead and replace b with a. That's going to be a cubed plus a cubed equals 2a cubed. Great. That didn't really help, did it? Of course, it's not going to help. We just checked what we found. We verified it at least, right? So that is correct. So how do we use this information? We kind of need to go back a little bit farther and further maybe. And figure out, okay, where does a and b come from? That's actually what matters, right? Okay, a is 2 to the power x, great. This is 2 to the x, and this is 3 to the x. So here we arrived at an interesting scenario where 3 to the x equals 2 to the x. How is that possible? They're different bases, same exponent, how do you get the same result? This can only be true if x is equal to 0, right? And you can also verify this, divide both sides by 2 to the x. And then from here you get this. And of course, you're looking for real solutions, then x will be 0. If you're not looking for real solutions and you're looking for non-real complex solutions, then that's a different story. But that's just for another channel, because I have a channel dedicated to complex numbers. And guess what it's called? A plus BI. Go ahead and check it out and let me know what you think. There's plenty of material. Watch the videos, look at the lecture notes if you're new to complex numbers, and let me know what you think. I also have a shorts channel, which I publish once a week. So I came up with a new schedule. I don't know if you've seen it. I've made a post. Monday through Friday, I give you the weekends for fun. You don't have to, I mean, you never have to do it. But I'm hoping that you will support my channel by watching the videos and making comments. It really matters a lot to me. So anyways, that's the new schedule. Monday through Friday, weekends are free. Now, let's go ahead and continue. Now, we found some complex solutions for t, right? Let's just take one of them. For example, t could be negative 1 plus square root of 7i divided by 4. What is that supposed to mean? Well, if you remember what t is equal to a over b. From here, a over b becomes negative 1 plus root 7i divided by 4. And of course, you can kind of replace a and b with what it is. It's 2 to the x, 3 to the x, and then you're going to have this complex number. And guess what you need to do? You need to do some type of complex logarithm, complex exponentiation, so on and so forth. But let me just briefly tell you what you can do. You can go ahead and natural log both sides, but for the log of a complex number, you have to use a special formula. Let me give it to you. If z can be written as r e to the I theta, then its natural log is going to be ln r plus e ln e is going to be 1, so I can just write it as I theta. Of course, theta, you can add multiples of 2 pi if this is the principal argument. And this one is a real value, the ln. This is a complex logarithm. Some people are going to write it as log, unfortunately, because they say, hey, this is the complex logarithm, not the real valued logarithm. Anyways, you get the idea, hopefully. You can go ahead and plug it in and do the rest. Because what I'm going to do is I'm going to show you a different way to go about it. So let's get back to where we had this equation, b cubed plus a squared b cubed plus a squared b equals 2a cubed, right? This is kind of like a 1b. Oh man, if I did a 2b, that would be interesting because I could then say 2a and 2b and then 2b or not 2b, but I still said that, too bad. So now, this is kind of like 1b, okay? Here's what we can do here. We can actually, since we can split the 2a cubed into a cubed plus a cubed, we can do that first and then bring everything to the left. But when we do, we're actually going to make it factorable by grouping. Just like the same idea, but we kind of split it up. This is difference of 2 cubes. You can do that, right? Like this. And then this one, a squared is a common factor, and you get b minus a. Now b minus a is a common factor, which gives you b equals a, so on and so forth. You get the idea? It's the same thing, but with a tiny bit of different flavor. Of course, the other one is supposed to give you the complex solutions, and you should be able to get that. But again, that requires some work for you to do. So let's go ahead and talk about the second method real quick, because that's actually what I was trying to get at. And this is hopefully something that you will use, because these problems appear on math competitions and Olympiads, and I'm hoping that you'll use this method. But again, it's up to you to decide. Now, for this one, our general strategy is follows. It doesn't always work nicely, but most problems are what is called contrived on math competitions. They work. So suppose you get something like a to the x plus b to the x equals c to the x. And you can have some coefficients here and there. That's fine. It don't make a big difference. Did I say don't? Anyways, you get the idea. But here's what we do. Whichever number is the largest, let's say b is the largest, okay? So b is greater than a in, let's say b is the largest. You can divide everything by b to the x. And you don't have to, by the way, but this works nicely. And then we get a over b to the x plus 1 equals c over b to the x. Of course, b is larger than both a and c, and I'm assuming they're all positive, right? Which means that now we get a nice equation. And our goal is to make one of these the square of another. You're going to know what I'm talking about. Let me copy this equation one more time and work with it so that you can see what I'm talking about. Here, in this case, the largest base, again, what am I going for? I'm going for the largest base. There are 3 bases here, 27, 12, and 8. And the largest among them is 27. So I'm going to go ahead and divide everything by 27 to the power x. Okay? That's our first step. And the rest is actually fairly easy. This is 1. This is 12 over 27 to the power x. As you know, if you divide 2 exponentials with the same exponent, then you just divide the bases. And this one is just going to be 2 times 8 over 27. Of course, make sure to separate the 2 out because it doesn't have an exponent, okay? Except for 1, of course. Now, how does this simplify, right? Remember what I told you. I told you that, okay, I want to make one of these the square of another. Forget what I said. You can also make it the cube of another, any power of another, actually. In this case, it happens to be the cube. But let's go ahead and simplify this first. Divide by 3, you get 4 over 9, right? And actually, I shouldn't say that like cube or square of another. In other words, here's what I'm trying to do. I want these bases to be powers of the same thing. And I think that's what I was trying to say. So, in other words, 4 over 9 equals 2/3 squared. And 8 over 27 is 2/3 cubed. So they're powers of the same number. That's a rational number. That's fine. Perfectly fine. But now what we're going to do is we're going to write these as follows. 1 plus 2/3 to the power x, and then I can just square that. You know that the powers will interchange. And then here, I can just write it as 2/3 to the power x, and then to the 3rd power. And now, this calls for substitution again. Call this a, b, c, whatever. Let's just call that u. You get 1 plus u squared equals 2u cubed. And if it's your birthday, happy birthday to you. From here, you get the same cubic equation. You can solve it any way you want. If you want to use the cubic formula, Cardano's formula, Tartaglia's formula, Ferrari's formula, Lamborghini, whatever you like, you can go ahead and use it. But this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe. Take care. Don't forget to check out SyberMath, the short channel, and aplusbi. And bye-bye.